For what value or values of A are the following vectors linearly independent? 1, 5, minus 2, 0, 6A, and 3, 13, minus 3. Alright, well, to do this I need to know what linearly independent means, and the definition says that the vectors are linearly independent if the only linear combination of the three vectors that I can do to produce the zero vector is 0 of the first plus 0 of the second plus 0 of the third. So what I'm interested in knowing is whether there's any more than just that one solution, because of course that solution's always there. So I want to know if there's more than one solution to an equation like this. A1 of 1, 5, minus 2 plus A2 of 0, 6A plus A3 of 3, 13, minus 3 is equal to 0. And I know how to solve an equation like that. I just put everything as columns in a matrix. So 1, 5, minus 2, 0, 6A, 3, 13, minus 3, 0, 0, 0. Okay, so I'm trying to find what all the solutions for A1, A2, and A3 are. If they're linearly independent, then there's only one solution, and that's that A1 is 0 and A2 is 0 and A3 is 0. If there's more than one solution, that would make them linearly dependent. And how do I tell how many solutions there are from my matrix? Well, if I row reduce and I get a unique solution, so there's a pivot in every column, then that means they're linearly independent because there's only one solution and it's everything 0. If I don't get a pivot in every column, so that means if I get a free variable, that makes them linearly dependent. So what I'm looking for is whether I can get free variables or not. So either way I'm going to have to row reduce, so let's give that a try. So let's look at this first column. I want the first column of the identity there, and I'd want a 1 here, and there's already a 1, and I want zeros here and here, so I'll do some row operations to get those zeros there. New row 2 is row 2 minus 5 of row 1, and my new row 3 is row 3 plus 2 of row 1. So row 1 hasn't changed. In fact, I'm not going to put the zeros there because they're not going to change. So I might rub them out now. Row 2, 5 minus 5 times 1 is 0, 6 minus 5 times 0 is 6, 13 minus 5 times 3 is 13 minus 15, which is minus 2. And row 3, minus 2 plus 2 times 1 is 0, A plus 2 times 0 is A, minus 3 plus 2 times 3 is minus 3 plus 6, which is 3. So I have the identity matrix column where I want it. Next I'd be wanting a column here with a 1 here. So let's divide by that 6 to get a 1 where we want it. My new row 2 is a 1/6 of row 2. So I haven't changed row 1, I haven't changed row 3. Row 2 is a 1/6 of 0, which is 0, a 1/6 of 6, which is 1, a 1/6 of minus 2, so that's minus 2 over 6, which is minus a third. So I want this to be the identity matrix column. I've already got the 1 where I want it, I just need zeros above and below. It's already a 0 above, need a 0 here. So if I take off A times row 2, that'll produce a 0 where I want it. So my new row 3 is row 3 minus A times row 2. So I haven't changed row 1, haven't changed row 2. 0 take A times 0 is 0. A take A times 1 is 0. 3 take A times minus a third is 3 plus A on 3. So I have my identity matrix column here. Next I'd be looking for an identity matrix column here, and I'd want a 1 here. And normally I divide by whatever's in that spot to get my 1. But the issue is, if there's a 0 in that spot, I can't divide by it to get my 1. If there's not a 0 in that spot, then I can, and I'll be able to finish it off to get a unique solution. If there is a 0, I'll get free variables. So whether it's linearly independent or not depends on whether that thing in the green box is 0. So let me write that down. Free variables, free variable, when 3 plus a on 3 is equal to 0. Let's solve that equation. 3 plus a on 3 is equal to 0. A on 3 is minus 3. Timesing both sides by 3, I get a is minus 9. So I have free variables when a is minus 9. So therefore, linearly dependent when a is equal to minus 9, because that's when we have free variables. Linearly independent when a is not equal to minus 9, because that's when we have no free variables. And that's the end of the problem.